Science Journal for Kids and Teens presents How Well Do Masks Protect Against COVID-19? Adapted from the original peer-reviewed paper in the journal PNAS, published on December 2, 2021. Research conducted by Gholam Hossein Bagheri, Birta Theed, and others from the Laboratory for Fluid Physics, Pattern Formation, and Biocomplexity at the Max Planck Institute for Dynamics and Self-Organization in Germany. See the full list of authors in the accompanying PDF. Read by Miranda Wilson. Abstract. COVID-19 has changed our lives. Since the beginning of the pandemic, many countries have introduced various restrictions. Most of us had to stay at home, distance ourselves from others, and wear face masks in public spaces for some period of time. 2 years in, COVID-19 is still affecting us. Many people still have to keep their physical distance and wear masks. So are these measures effective? We tested what would happen if a sick person and a healthy one got together and talked for some time. We found out that social distancing alone isn't effective. There is a 90% chance that a healthy person 3 meters or 10 feet away will get infected in less than 5 minutes. However, if both wear a protective mask, this risk goes down considerably, even if they are standing quite close together. Introduction. It's been 2 years since the beginning of the COVID-19 pandemic. Even now, many of us have to wear face masks and distance ourselves from others. But why is that? SARS-CoV-2, the virus that causes COVID-19, spreads through small droplets. We produce them during coughing, sneezing, speaking, and even when we breathe. And if we carry the virus, even when we don't realize it, there will be virions in these droplets. Thus, we can infect others. The droplets can be big in size, above 50 microns, and then they fall quickly to the ground. In this case, we have to be pretty close to another person to infect them. But droplets can also be smaller, meaning that they can stay and travel in the air for quite some time. And when they travel so far, they may shrink as evaporation takes away some of the moisture. It's alarming that SARS-CoV-2 can spread with such ease. This is why wearing face masks in public places is mandatory in many countries. Governments also often encourage or require social distancing. But do these measures stop SARS-CoV-2 from spreading? How much do masks and social distancing reduce the risk of infection with the virus? This is what we wanted to find out. Figure 1 shows the interaction between droplets and masks. We'll explore this figure in depth in the methods section. Methods. We invited 130 healthy volunteers from age 5 to 80 to help us figure out what we release into the air. We measured the droplets they produced while breathing out and talking, both with and without masks. We also compared 2 different types of masks, FFP2 masks, similar to N95 masks, and surgical masks. Now, imagine 2 people are facing each other and talking. One of them is infectious. They carry the SARS-CoV-2 virus. The other one is susceptible. They have no immunity against COVID-19 and can become sick. We considered 3 scenarios. 1. Neither one is wearing a mask, but they keep a distance. 2. Only the susceptible person is wearing a mask and they still keep a distance. And 3. Both are wearing masks and standing right next to each other. The risk of infection in the first scenario depends mainly on the viral load, infectious dose, and how much people's breath dilutes in the surrounding air. We assumed the most common values for these parameters that many researchers report. For the other 2 scenarios, we also had to estimate what percentage of the droplets might leak in and out of the masks. There are 2 main ways for this leakage to happen. The droplets either penetrate the filter itself or slip around the edges. To estimate the leakage, we used a particle-size spectrometer. It allowed us to count particles in the air and inside the mask. Comparing both counts gives us an accurate idea of what goes in and out of the mask. Here in Figure 1, you can see that masks protect both the wearer and the people nearby. Still, some droplets leak out and in of the mask, both through the filter itself, represented by the big arrows, and around the edges of the mask, represented through the little arrows. You can see the person on the left breathe out droplets, which can be seen as little black dots. The red paths represent the potential paths that these droplets can take out of the person's mask and then into the other person's respiratory system, where they can be seen highlighted in green. Results. The bad news is that social distancing alone doesn't protect against infection. Even at a distance of 3 meters or 10 feet, there is a 90% chance the susceptible will become infected in less than 5 minutes. However, if only the susceptible wear a surgical mask, it will take at least 30 minutes to become infected even at a distance of 1.5 meters or 5 feet from the infectious. And if the susceptible wear an FFP2 mask, the chances of infection even after an hour are only about 20%. Of course, the best scenario is when both the infectious and the susceptible wear a mask. If both wear surgical masks, the risk of infection after 1 hour is below 30%. And if both masks are FFP2, the risk stays below 0.4%. Figure 2 shows more detailed results for various mask combinations. Figure 2 shows the risk of infection after 20 minutes when both the susceptible and the infectious are wearing masks. These are shown visually in the graphic using a representation of a face wearing a mask, where the mask color indicates the type of mask worn. Capital F represents a well-fitted FFP2 mask and can be seen in green. Lowercase f represents a not adjusted or loose FFP2 mask and can be seen in white. And capital S represents a well-fitted surgical mask and can be seen in blue. Each face represents 2 people. The left half indicates the person who is infectious and what mask type they are wearing, while the right half indicates the person who is susceptible to infection and what mask type they are wearing. In the graphic, you can see every mask combination along the x-axis. For example, capital S, lowercase f, means the infectious person is wearing a well-fitted surgical mask and the susceptible person is wearing an FFP2 mask that isn't adjusted to fit their face. The y-axis of this graphic represents the infection risk in percent. Looking at the graphic, which mask combination is the safest? And which is the least safe? Discussion. If people depend only on physical distancing, the risk of infection is very high even after just a few minutes. This doesn't mean we should stop doing it though. Droplets containing virions are unlikely to reach us when we are 3 meters or 10 feet away. The closer we get, the more likely we are to be infected even in a short period. But masks are definitely the more effective measure. If the susceptible wear a mask, it reduces the risk a bit, but not much. If you talk to your infected friend for an hour while wearing an FFP2 mask, there is a 1 in 5 chance you'll get infected. And if you wear a surgical mask, you'll get infected after only half an hour. Everyone wearing a mask is the best way to protect ourselves and others. It's important that you fit the mask to your face by adjusting the nose piece so the mask edge is against your skin. That's how you reduce the leakage of droplets. If you don't adjust your FFP2 mask, the risk is much higher. It increases tenfold compared to a well-fitted mask, and even a loose FFP2 mask protects better than a well-fitted surgical mask. Figure 3 shows how to adjust your mask for a good fit. Push in on either side of your nose so that the mask edge touches your skin. This reduces the amount of droplet leakage. Conclusion. Our results show the high end of risk based on the experiment parameters. In real-life situations, they can be lower due to various factors. Still, Wearing either an FFP2 or a surgical mask is a very effective measure to stop the virus from spreading. Wearing a mask outside and at school can be annoying, but doing so means you protect not only yourself, but also your family and friends. When you do wear a mask, don't forget to fit it well to your face. Remember not to touch your eyes and mouth either. And of course, wash your hands often. Thank you for listening to this recording. Visit our website, sciencejournalforkids.org, for more free science teaching resources.